pass those pieces of paper that you had to the person who made the presentations.
All the blue ones again. Where is Joe up there?
No, Joe's over there.
Oh, back in the back.
And where is Blue?
Right here. Can you see my? Can you see it?
All right, those of you who got your feedback forms, look them over and pick one or maybe two that you think was most beneficial to you, and hand those to me before you leave today. Those people will get kudos points, whoever they are. All right. I heard the phrase, "as you can see," 8 times today. I don't want you to say, "as you can see," ever. Because what the presenter sees may not be what you see. So you can say things like this. I'm going to show you where the x-axis is, and the units are percent. Don't say, "as you can see, the x-axis says percent." You get the difference? If you want somebody to see something, you show it to them and point it out. This is blue, this is green, this is fuchsia, I guess, and this is pink. Notice how I pointed out what I wanted you to see. Now, I want all of you together to say, "as you can see." Go.
As you can see.
I want you to do it louder. Go.
As you can see.
Even louder. Go.
As you can see.
Now I want you to do it 8 times as fast as you can.
As you can see. 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 As you can see.
Who wasn't participating? Somebody, I didn't hear 46. You didn't participate?
No, I didn't. Get a tongue twisted.
All right, so are you used up of saying that? Or you want me to have you do it 16 times? You good? Okay. No more this semester. Let's talk about agreements. I'm going to pick one at random. Just look at pink agreements here. Let's see what the pink agreement the team agreed to. Oh, that's in the wrong place. Agreements. They agreed to certain things here. Communication, no fighting, provide constructive criticism, and provide help. It may be that your team may want to get together and revise your team agreements after you've seen what happened in the past few weeks. So you can do that. You can revise your team agreements based on whatever you want. Did you read my email yet, Nick?
Yes.
Nicholas?
Yes.
What did it say down at the bottom? There was a question, wasn't it? Do you remember reading that and there was a question down at the bottom?
Would you like for it to be
Would
different?
you stand up and state the question as you remember reading it from me?
The question was, would we like for the pressure booth and the temperature booth, I believe it was, to be separate versus time shared? Would you like for that to be different, was the exact wording of the question. My response was yes. A resounding yes. Would like for that to be different.
Okay. Somebody here in this room today, I asked a question. No, it was out in the hall. Somebody I asked a question. Stand up and state your name and your team name and what the question was I asked you.
Ronnie Lane. I am Aqua, and he asked if we could. Would you like the system to go faster? And I said yes.
Isn't that interesting? Y'all are in temperature?
Yes.
Y'all are in temperature? Y'all in temperature? Y'all are in temperature? Y'all are in temperature? Y'all are in temperature? Huh?
Yeah.
All? Anybody like the speed of temperature and want me to leave it the same, or would you like me to speed it up?
Speed it up.
I don't think everybody said something. Did you say something, Mary?
Well, is it going to change the data or not?
Pardon?
When you want to speed something, usually change the data, so you're not going to get the same.
Well, I'm not sure that we understood each other. Somebody tell me how long a temperature experiment typically takes.
12 to 15 minutes.
12 to 15 minutes. And pressure, how long does it take?
Seconds.
12 to 15 seconds. Would you like to stay with an experiment that runs 12 to 15 minutes, or would you like to have one that runs 12 to 15
I
seconds?
thought you would like take the system and just like do something to the system to get like faster data.
I'm not going to tell you what I'm going to do. I'm just asking you, would you like to for it to be faster? Would you like for it to be faster?
Yes.
All right, everybody who would like for it to be faster, say, like for it to be faster, Dr. Henry.
Like 45 minutes.
Now, the pressure people had a pretty fast system. But you happen to be bogged down occasionally by people who are running on the same unit with pressure, which was temperature. How about the temperature people? Would you like those, the pressure people, would you like those temperature people to be moved somewhere else?
Yes, Dr. Henry. Move them somewhere else.
All right, I'll work on it. Oh, let me show you some things. Somebody in here is an environmental engineering major, aren't they?
Yes.
Who's that? Okay. Let me show you something. I got this book yesterday in the mail. Probably a $200 book, but they sent it to me for free. How about that? Sweet? All right, I'm going to show you some things in this book. Here is a diagram. What's that look like?
Blurry.
Blurry, looks blurry. Okay, there you go. Is that better? It's a diagram. That's a schematic diagram like I like to see for you to draw for your system. Looky here. What do you notice?
Steps.
Here's a graph. Time is on the x-axis, and something like concentration is on the y-axis. And the concentration changes at some point in time. What do you call that, Nicholas?
The step response.
Didn't you say that already?
I did.
And look at this, what's that?
Pulse.
That's a pulse. So these things that you're working with, oh, look at this one. Oh, is that fascinating?
That's frequency response.
It's what?
Frequency response.
It's that's a sine wave. Yeah, we're going to do that, but not this week. Not this week. Hold on. We're going to do step response this week. I just wanted to show you that. That's what's going to be coming up. Looky here. What's that? Look at that. Days. Not minutes, Marion, but days. How would you like to run an experiment that took days?
Very much.
80 days.
Who can pay?
Who would do that?
System.
Environmental engineers and other people, maybe geology engineers, maybe civil engineers, maybe real dumb electrical engineers. Don't tell anybody I said that, okay? People who get paid for doing experiments might do something that long. Here's another one like that. Oh, look here. Here's a breakthrough curve. Look at that. What could you do with that? Put it in the book. You could draw a tangent here and see how long that took. And things like time response and dead time. Oh, looky here. Another diagram. This is a block diagram. More block diagrams. Block diagrams must be used from time to time in different engineering assignments. Ah, look at here, another one of these. Don't you love it? What's nice about this one, David, what do you notice, David Dodds, what do you notice? Is it Dodd or Dodds? Singular?
Yes. No.
What do you notice about the units here? There's no numbers and there's no units. Cool, huh? That's always the way to hide things. You want this?
I would love it, yeah.
That's okay. Let's see what I can find in this random book that I picked up off the table. Oh, have you read page 11 yet in this book? It's page 11. Chapter 8 discusses PID controllers. We're going to do that this semester. And et cetera, PID, Ziegler and Nichols proposed the so-called Ziegler-Nichols tuning rules. These are things that we're going to study very soon in this class. Well, very soon in geologic time scale. In 1942, how many of you have read an article written by Ziegler-Nichols? How many of you remember that I suggested that you might read an article by Ziegler-Nichols? 1, 2, 3, 4. And why did I ask you to read it? What did I ask you to do after you read it?
Presentation.
Pardon?
Your presentation.
No. The first paragraph or two shows. I'd like your feedback on the first paragraph or two. That's all I'm asking. In this here book, on page 170, something they call delay time T sub D. Do you suppose that's what we call dead time? Has the same initials, delay time, dead time. You suppose that's the same thing that we call dead time? Let's turn the page and see if there's a graph. Here's a graph. You're going to see graphs like that. They call delay time this time here. Up when it goes up, when it gets 50% of where it's going to go. So delay time in this book right here, on page 170, 169, is not what we were talking about. Is that good news? Well, now that you know it's not, that's okay. Here on page 417, there's something called transport lag. Transport lag, which is also called dead time. Notice that here's a phrase we use, right? Dead time is